Swayam Prabha. Digital India. Educated India.
Today we would be talking about material properties of geosynthetics. As I just mentioned in the previous class, the geosynthetics have been very useful in ground improvement projects. Hence, it is very essential for us to understand what type of materials they are composed of and what are their applications. Of course, we have seen that they are very useful in many applications, and how do you identify them, how do you characterize them, what are the properties required for different applications we should see. So, in this lecture we would be seeing how the polymer material that exists in all these geosynthetic materials is determined, how to evaluate the mechanical properties and hydraulic properties and all that. Actually, we should first of all identify what is that material. In fact, if you have a geocomposite or a geogrid or a geotextile, we should be able to identify what type of polymer you have, because as I just mentioned, they are all polymeric materials, chain of carbon and hydrogen atoms. You should be able to know about geometrical information, what is the thickness, grid opening size, and what is its mass per unit area, like what is the weight of that material. That there is a general product information. In fact, if you want to identify the polymers, there is a test what is called differential scanning calorimetry, in which you have a sample here, then you heat you have a sort of a control heating, and then once you heat raise the temperature, there is what is called heat flow is monitored as a function of the temperature, and there are certain products depending on the type of polymer, they give certain signatures, like say for example, here you have a crystal melting point which is number 6 here, like these are all this is a graph and all that, you will have a result like this. Then the crystal melting point is somewhere here, it is a function of the type of polymer you have, and so that can be used as a basis to identify the type of polymer. So, for example, here you have the polypropylene product, you have a about 164 degrees 0.29 degrees centigrade, you have this type of result you get, and people can use some of these materials for whatever is the application that we are interested in. The geometric application, actually the thickness is quite important, because we have seen varieties of materials, they have different thicknesses, and as I just mentioned, we have to standardize at one pressure. At 2 kPa we measure the thickness, actually this is the thickness of the sample, this is the weight and area of cross section is there. So, we try to calculate its thickness, because this is required in many of the properties like permeability, like if you want to look at filtration and drainage criteria, thickness is a very important parameter. We also need to know its mass per unit area, which is called MUA, and it is one of the very important applications here again, and you try to take a small circular piece of geosynthetic material and then weight. So, you take its weight, and in fact, as I just mentioned, the quality of a paper and the quality of silk is also measured in terms of mass per unit area. This is how we do it, we take some samples and then weigh them, and then you have a property, it should be nicely cut, because there is a special cutter there that should be used. Mechanical properties is what we need in most of the applications. So, we are looking at short term tensile strength and its corresponding deformation, long term tensile behavior, like it can be in terms of the long term means the time dependency, like you just wait for different periods of time and then find out if what is the change in tensile strength. Then long term compressive creep with and without shear stress. In fact, we do this in soil mechanics, like we apply load and then at the same stress level we allow it to settle for longer time, we call it creep behavior. Then we also have what is called resistance against impact or punching, this is another test. This is all required in many of the, like as I just mentioned, survivability requirements are there for geosynthetics. If they have to really perform well, they have to go through some of these tests, like so for durability you have a resistance against abrasion, and friction properties, like we know that friction between the soil and reinforcement is very important for effective working of the reinforced soil structures. So, to measure the frictional properties you have direct shear, inclined plane test, pull out resistance tests. We have production efficiency test also, which will tell you about if you have, if you want to protect a particular product, and so you need to have some sort of cushion for it. So, is a product does have that production efficiency, is it not? That is what we would like to see here. Damage during installation is another one, and there are many properties that we need, even say for example, if you are trying to use a composite segmental block type of structure in the case of a reinforced earth walls. I just showed in the previous figures, previous classes. You need to even do a test for that. In fact, short term tensile strength means immediate tensile strength, and you have certain standards for it, and this specimen size is at 200 mm by 200 mm. This is a size, and then the strain is given also. These are all, actually you have European standards, you have ISO standards, you have ASTM standards. All these three things are very important, because if you are in Europe you may try to follow it. ISO is a general standard, ASTM if you are in US they go by ASTM standards. Mechanical properties, you can see that, this is a material that is being tested, here is a geogrid or a geotextile here. So, testing machine with video extensometer, like they see that deformation in the strain using sophisticated equipment such as video extensometer. Here they are trying to use laser extensometer. You have a geogrid here, you can see that it is being pulled up and they are trying to measure that strain. So, these are all different standards as I just mentioned, and then there is a rate of application of load is also mentioned, 100 mm per minute, okay. And so, this is like, say in this case it is 20% per minute, like this they have some. So, this is a sample size here as I just mentioned, these are all sample sizes. If you want to look at the response, say for example, strain versus kilonewton per meter length is what you observe. So, you can have varieties of stress strain curves depending on the material stiffness, like you can have varieties of, this is what is going to be very important if you are trying to design for reinforcement functions. And the other important property is called tensile creep, like you are doing a tensile testing, but then you apply the same load, but still there is a creep, there is a load that is applied. So, the tensile creep is an important parameter, it gives information on the time dependent deformation at constant load, and then sometimes there is it also fails. So, it is called rupture. So, sometimes you see you keep on pulling the same material or the same load is applied, it because of the molecular arrangement as I just mentioned, even with because of the time there is a deformation that occurs even if the load is same. So, that needs to be calculated. So, we use constant loads, we will just see that this is like this, say you have a geotextile piece here like 1, 2, 3, 4 pieces, you have constant load applied, or you can even a lever arm application is can be there, and multiple creep rupture risks in a temperature controlled chamber. In fact, in a chamber where you have multiple materials tests are being done and all that, this is one. The way that results can also be plotted is like this, one can say for example, you can plot some of this different strain level, different loads actually, different loads like say for example 50 kPa, 100 kPa, and different loads can be applied, and you can monitor this creep curves versus time. Say for example 50 kPa one load, keep on observing its deformation, you will get a strain like this, maybe 100 kPa like this, 1000 kPa like this. So, at some higher stresses what happens, the curve may show like this little kink also, which means that there is a rupture there and it can't take higher loads, that is what it means. And so, creep rupture is one possibility, this is the way that we construct creep load curves, and from this we construct what we call isochronous curves, which means that at the same time we would like to see what is its effect of say for example here the tensile strength of that geogrid is or geotextile material is 35 kilonewton per meter, and this is the stress strain curve immediately after the ultimate tensile strength immediately after the product is delivered to you or something, immediate is a rapid test. Then after 1 hour this is one test, one stress strain curve, and then like 1 hour, like 10 hours, 100 hours, 1000 hours and 10,000 hours. So actually code recommends, say for example we want to calculate, see the thing is that why is this isochronous curves are required is that you would like to estimate the tensile strength of the material after say in its lifetime. So for example 30 years you would like to construct or 40 years you would like to construct. So if you want to correct, you need to have how much of degradation strength reduction is there from immediate condition to long term condition. So we measure this, we get this information from this curve. So different materials have different properties like this, and you can use this as a basis for correcting your tensile strength in the design, that we will see. So for example if the tensile strength could be 35 kilonewton per meter, then if you want to see that it works for about say for example 50 years, you may have to use a factor of creep factor of 1.3 or 1.5 or whatever. So it depends on this type of testing. Okay. Then it's another thing is a compressive behavior, like as I just mentioned, many of these materials are also compressible, right. So one can see that compressibility behavior as well in under different confining pressures. Particularly this is very important in the case of a drainage products, because as I said water flow is very important, and if the compressibility is going to be more, the drainage is less. Compressive creep in another product which is called cuspated fin drainage product, like it is like this, it is another interesting project that we have, which we use it for many of the drainage applications. Say for example in the case of retaining wall, it looks like this, you can see that it has some sort of projections and all that, it is fins, they are all called fins, there is. So instead of putting a backfill next to the retaining wall, you have a material like this which can be useful as a drainage material, and then it is going to be very permanent, and where and then thickness is also much less, and it is going to be much cheaper compared to sand or any of the gravel material, right. So these are some tests that one should do. And resistance to static puncture, actually this is actually a modification of the CBR test, because what we do is that here we try to use this test for things like this, CBR test, we try to make a puncture here, we try to measure the load here, essentially we try to say similar to CBR test, we measure the load versus deformation. Here also we get the same thing. See how much of load it can take is like you will get this, like this is on a polypropylene tape fabric. There is also, say people have, the thing is there is a textile industry, actually people in the textile industry, they are also used to tensile testing and all that. They have used some of their testing methods to even characterize the geosynthetic materials. That is the reason we have what is called a pyramid puncture test also, in which you have a material like this, and this is as per the ASTM standard, and here is that material, and this is like this. You have a dynamic puncture test in which a cone is dropped from a height, about a 1 kg pointed cone is dropped from the height of about 1 meter onto a specimen, held tightly in a circular clamp. The diameter of the hole created is measured by means of a graduated aluminum cone scale. So what is the diameter it has, all that there are some measurements like how much of puncture it can give. In fact some of these tests are index tests, but they are very useful in deciding about the product. So this is that cone drop test. There is another test called impact resistance test, in which again here a spherical shaped weight is dropped onto the lead plate and on resilient base. The impression in the lead and the condition of the specimens are recorded. Lighter round shaped drop weights are used for other geosynthetics. The deformation of a metal sheet under tested material gives quantitative results. This is what is called impact resistance test. This test is in many of the standards here, ISO standards as well. This is how it is done, like as I just mentioned, a small drop weight lead platen specimen and ring, and this is what it does. You can see that this is impact resistance is a standard test actually. This is how it is done, layout, and this is how after that this is another same type, and the result is yes, penetration yes or no, that is what it shows, and if there is no penetration it is supposed to be good, like that. There is another test called abrasion resistance test, like emery cloth of the specific grade is moved linearly along the specimen. After 750 cycles, the abraded specimen is tested to measure the residual tensile strength or hydraulic properties. Actually what happens is that abrasion is one important property where it can influence the both tensile strength and hydraulic properties. So we try to have a geosynthetic material here and then subject it to 750 cycles of rubbing actually, using emery cloth, okay, or specific grade. So you can see that before test, like a geogrid was like this or a geotextile, after the number of repetitions it is like this. This is also an indication of the quality of the material. So they also get the force versus displacement of an abraded specimen to undamaged specimen, like this is undamaged one, this is all damaged ones. So they try to measure. So depending on the type of material, you can find out its thing also, like what is its tensile strength. Depending on there are two directions, in a geotextile you have a warp direction, weft direction, and there is the standard textile engineering terminology. Then there is another one what is called direct shear friction. Here the direct shear friction is something that is very important, because as I just mentioned, its reinforcement reinforced soil is essentially because there is a friction between the soil and reinforcement, and that friction is converted as a tensile force. So you have to really measure the friction. If you want to see if a geogrid or a geotextile material is going to be good, you have to find out the friction, like similar to our friction angle of the soil. We try to calculate the friction angle of the geosynthetic also, like we call it angle of interfacial shear resistance, like similar to tan delta, which we use in soil mechanics. It is similar to, we normally have a tan phi, but if there is a pile foundation, we say that we use a factor called tan delta, which is nothing but 2/3 of tan phi. So similar to that, we have a friction parameter here, which is a combination of ratio of normal stresses to shear stresses. You get from this, actually it is a ratio of shear stresses to normal stresses, and so the direct shear test is done, that is one thing, and this is like this, direct shear test we are familiar, and okay. What we do is that here it is one thing very important is that see our direct shear test, whatever we have, it needs a bit of modification, because you must be able to, in a direct shear you do normally a small sample. Here you need to do for a big sample, say not less than 1 foot by 1 foot or something like that, which represents the actual field condition. So you must be able to take a geosynthetic material here. You can see that there is a horizontal reaction applied, there is also a normal force applied. In fact, one should be able to see here the direct shear box size, you can see 300 mm by 300 mm. The size is quite big, and so this is a shear force is applied like this, okay, and the normal stress are there. So that is one type which we are familiar. There is also another test which is called inclined plane test. Here the friction parameters, like geomembrane to geosynthetic material, there are so many friction between two materials. One is geomembrane geosynthetic in a landfill, geomembrane soil, geosynthetic soil. So whatever is that combination, you have to put an inclined, say for example one can have a table like this, any table, and so the movement of the upper box and an inclination are measured while lifting the table by 3 degrees. Say for example you have this a particular box is kept, and if the table, if the angle is slightly changed, so you try to see the movement of the upper box and its inclination, and both will be measured. when the upper box moves 50 mm, the test is stopped and the angle of the table is taken as the angle of friction for the chosen materials combination. So, whenever the box moves about 50 mm, then we stop the test and the angle at which the table is inclined is taken as the angle of friction for the materials. So, that is very important. In fact, there are some landfill failures that occurred. What happens, as I just mentioned, though these materials are very nice, so I told you that geosynthetic membrane is very smooth, and if you really do not measure its properties properly, then there is some failures occurred in we have it in literature. So, one should measure some of these properties properly, and so here what they do is that you can get this material here, the friction angle here, and then normal stress must be recalculated for the resulting angle at the end of the test. This is also very important. So, you can see that a typical result corresponding to a 50 mm, right, is taken as the angle of friction angle. There is another test which we have to do, is called pull out test. Actually, as I just mentioned, the concept of reinforced soil, you have a friction in the active zone, and it is a it has to be hold in a position here backside, that is called pull out resistance. So, that pull out resistance is very important for effective functioning of the geosynthetic material, and the way that we do here is that we calculate pull out versus deformation. You pull out a geosynthetic material, or even I will show you in the case of a soil nail, just maybe in the next lecture, you try to pull out the material and calculate its resistance. So, that is what we do. So, we try to plot the results in terms of the how much of mm it has come out, what is the load it has taken. So, force versus deformation are recorded like this, okay, elongation of this thing. So, different force. So, you will have this, like what you are doing is that this is a soil, this is a soil, you try to pull out this material, pull out device is there, you have some it is a big sample actually, you can't do samples of small size here, it should be to really to be realistic with what you call the field observed field conditions, we should do big samples, okay. So, this is one type that we are doing. Then there is another test, what is called protection efficiency. Protection efficiency is the ability of the geotextile to protect a geomembrane. It is quantified by a test based on German procedure. In fact, I was working in this laboratory in Germany where they developed this method. Actually, as I just said, landfills are there. Landfills are, you have to have a geomembrane. Actually, geomembrane is a very important thing, that the permeability is very low there because of geomembrane, and if a geomembrane gets punctured, then it is a problem. So, people have a what is called a protection layer. So, you put a protection layer, and this is nothing but it is a simple experiment that they do, like I will show you that. See, this is a type of test they developed actually. So, 7 is a geomembrane, then you have a geotextile. This is actually the aggregate. Actually, see, we normally use in the landfill aggregate as a, even in the pavement also we are using aggregate as a drainage medium. So, but then the drainage medium should not puncture the geomembrane. So, we try to put a geotextile as a protection layer, and we try to find out its indentations here like this, and then we try to calculate how much of indentations or depressions are created. There is what you call, if there are not much depressions, then the protection efficiency is very good. If there is lot of depressions, then yeah, I mean the material is not that good. So, we need to really people do some sort of testing. In fact, it is in the institute where I was working, it is called Landesgewerbeanstalt Bayern, it is in Germany. They developed this test because they had lot of normally they do innovations actually, so this is a standard, worldwide standard now. And there is another test, what is called, if you want to understand what is the damage that can occur during installation, again this is an European standard in which you have a cyclic loads applied 200 cycles between 5 to 900 kPa and the maximum stress is assumed, and so after the maximum stress this specimen is removed, and again you test it for tensile test or a filtration test. So, you are actually, the thing is, as I said, damage is also should be simulated, whatever is the condition that you have in the field, the moment actually the geosynthetic product may be fine in the lab you can manufacture conditions are all right, but when you are trying to use it for a specific application like a drainage or a filtration, you should be very good. So, we have to really simulate see the damage of the particular product, and if the damage should be simulated, there is a method of doing it, as I said, after 200 cycles between 5 to 900 kPa. So, we try to remove that and then tensile testing is done. Okay. So, this is what we call as a performance test. So, this is for example, this is like this: damage during installation, filling up in this corundum box, this is that geogrid material, and cyclic loading is applied, and this is all geosynthetic specimen surplus rolled carefully outside this container during the damage procedure. So, these are all some sort of testing that is done, and once it is done, you will see the difference, like material is before damage, it is like this. This is after that, this damage is like this. So, people try to quantify its tensile properties or whatever properties one can find out. So, that is we have some more tests like what is called for composites, particularly when you are trying to have geosynthetics can also be converted to geocomposites. You can have a geotextile and a geomembrane together, a combination. So, when you are trying to combine them, there is a possibility that if the junction, like you are trying to seal them together. So, if the failure of the internal junctions is likely, then it is risky. So, you have to test these junctions using some appropriate testing. So, for example, geocells, like as I said, geocell is a combination of it has a number of polymeric compounds in which you can open out, it forms a geocells, but you can close it like this. So, all at the edges they are all sealed together to form the cell, they are all sealed. So, that sealing has to be very good. So, the internal geocell connection we call it, it should be tensile shear resistance has to be very good, peeling type it can be peeled off also, then splitting type it can be split also, or a combination. So, none of the failures should occur. So, we try to test them for a typical junction strength. Say for example, this is what I mentioned was a geocell. Okay. So, this is what is called junction strength. Okay. So, if that is not good, then it is not going to be very effective. So, you have to test this particular junction strength. So, you try to calculate that here using the procedure. Then another important property that we should see are the hydraulic properties, so when water permeability characteristics, as I said, filtration we call it when the water flow is like this and only the water is allowed, not the soil, that is called what you call filtration. So, for this we need to find out, we have again the simple tests, constant head permeability test, falling head type of test, and water capacity in the plane. We calculate the what is its flow capacity also. Then there is what is called characteristic opening size. Say for example, all the geotextiles have some opening size. I told you that, say for example, you take prefabricated vertical drains, I just mentioned in the previous class for improvement of soft ground. One is a filtration characteristic, the other one is a drainage characteristic. The filtration characteristic depends on the size of the the water should only enter, should not the soil. So, the characteristic opening size of the geotextile or the geofilter is very important there. Then water flow capacity, say the thing is how much of water is it can take, what is its drainage capacity is another important variable. So, some of these things should be known very well, so that you can design it properly. So, again we have a lot of testing procedures. When geosynthetics are working as filters, they are required to allow water through freely, but not the soil grains. So, sometimes some very fine grains are allowed through such that a stable secondary filter is developed in the contact zone. There is a small theory for that, like sometimes the next to the filter small particles may not go. So, they just sometimes they go also, but there is a possibility that there is a small secondary filter that can develop in the contact soil zone, like wherever that contact occurs. So, water flow may be determined at stationary time conditions, or these are all some tests depending on whether it is constant head or a falling head one needs to do properly, because we should know, we should assess the field hydraulic conditions. So, for example, if the hydraulic gradient is not going to be very high, then one type see, then it is fine, like you can do a simple what is called the constant flow type of test, or simple test one can do. But if the head is highly variable, say for example, you are trying to test the geosynthetic material at the bottom of a landfill, the landfill head is leachate head will be about say 5 meters. So, the thickness and the head is quite high. So, definitely you need to do a falling head type of test. So, there are some tests here, unlike what we studied. You can see that this is a geotextile material, okay. It is not a similar type that we know in soils. So, deaid water passes through the charged specimen with so it comes like this, and then you measure this, and this is what is called for the horizontal permeability, okay, where geotextile is placed. This is again a vertical, this is another one that you can keep like this, vertical permeability can be measured, okay. So, this is another type where you can measure the permeabilities at different gradients and all that. So, essentially this is a simple setup that people have developed to understand what is the geotextile permeability, okay. So, it can be even for from flow versus time is measured, and you have that using the Darcy's law one can calculate the permeability. Then falling head, again similar thing was done here, again deaid water, in fact in permeability testing we should use deaid water, because you do not want air in the water, and the deaid water passes through the specimen charged with normal stresses from top to bottom, and multi-layer specimens can be used, flow versus time is measured, and you can calculate the permeability. There are some specific equations there. There is another test which is called in plane permeability test, like as I just mentioned, geosynthetic drain we can call it, it can work as a drain also, like so you are trying to measure the drainage of this material. So, you have a simple setup that is fabricated here, like some of these tests can be fabricated in the lab also, following those standards, like you have an ASTM standard or this thing, it mentions clearly the size of the tank, the distance to be maintained, how do you place the material, what is the cleaning procedure and all that, they mention everything. So, you can follow the same test procedure and use your geocomposite here, in fact a geocomposite can be placed here, and then you can measure the drainage capacity. So, water flow is what you are trying to find out here. So, this is the type of test, okay, for the in plane flow test. This is a specimen in upper test, net core with soft contact. So, this is that you can see that very clearly, that geocomposite net core, geonet is nothing but a drainage material. So, they have placed that material here and then they are testing it, okay. This is a very important thing. So, flow is measured at constant water head and expressed either as permeability in meters or the flow capacity per unit width, like per width at a given hydraulic gradient. So, for different hydraulic gradients we can get this material, like so the flow is dependent on the thickness of the product, as some products compress under load and the flow values are time dependent. So, for long term design, flow values need to be corrected for compressive creep of the product. This is very important, as I just mentioned, like in fact I did couple of tests on this type of material, where for a coir drain that we developed, we are looking at its in plane capacity, because in a coir drain its drainage is very important, and so we have to measure the the water capacity, in plane water capacity, how much of water it can take under different pressures like 20 kPa, 100 kPa and 200 kPa. Because say for example, in the coir drain I am putting for say 10 meters deep, 10 meters means it is a considerably deep. At 2 meters the pressure is 2 into 20, say for example 20, so 40 kPa, and at 10 meters it is 200 kPa. So, it must be able to see the drainage function satisfactorily. So, I must be able to see that there is that the in plane adequate in plane flow is there all the time. That is what I just want to say. And as I said, it is also a function of the hydraulic gradient. If higher is the hydraulic gradient, higher is the in plane flow. Like if you have a good gradient, definitely there is a good water flow. So, that also should be measured, okay, because we must have an idea of what is the hydraulic gradient that one can expect in the field. How do you get this? You have the information from flow nets and seepage and all that. Like you have to do a relay flow analysis, and you should know how much of head of water is acting, and say for example you have a dam you want to, so you can calculate for a dam what should be the drainage required, so that so all that one can make calculations. Essentially I would like to say that the drainage is an important parameter, and it is a function of the material, its size, thickness and also the load applied. As I just mentioned, the apparent opening size or the size of the geotextile is another important parameter. Like see, we know we design the filters based on gradation size. We say D60 size, D10 size, D30 size and all that. Here we try to calculate what is the characteristic opening size, which is nothing but it is it's 90% of the material can pass through that. So, to determine which grain size can pass through a geosynthetic and which is retained, a wet sieving test is used with a standard soil. We take a standard material and pass the standard material. Let us say for example, you have different glass balls of different sizes, say for example 0.1 size, 0.01 size, 0.05 size and all that. You try to pass through the geotextile, and where 90% of the material pass through, you can designate that size corresponding to that 90% as the O90 size. So, O90 is nothing but the D90 of the soil passing to the geosynthetic. It is very clear that you have any material which has some small, it can be 0.01 only, but you try to do a proper analysis like this, that becomes O90. Okay. So, because this is very important to define the filtration criteria in geosynthetics, we will see that later. The way that test is done is like this, like you just put water and try to calculate, and different sieves are there. Of course, this is all in German, and because this is material that we get from them, and this is how it is done. Cumulative passing, say for example you have different 70 to 100. So, you can see that O90 size is this size. So, this is a very important one that we will be using later. So, tests according to the other standards use a simple gradation get characteristics or glass spheres to measure similar properties. As just mentioned, you can have a sand also, fine sand also, or a glass spheres, right, to measure the properties. So, this is how we get it. Another important point that we should see is that material durable. What you saw earlier was, first is mechanical properties we have seen. First is we have seen how the material is identified, the second is mechanical properties, third one is hydraulic properties, and then the durability properties. Actually, we have also seen endurance properties, like number of cycles it can go, like abrasion tests and all that we have seen. After that, durability is another important issue that we should see, because if the geosynthetic materials are not do not exist, say for example 30 years, then it is risky, you can't use them, because our life cycle, we are trying to design buildings for about 50 years. So, you need to see resistance to weathering, resistance to microbial degradation, resistance to liquids, resistance to hydrolysis, resistance to thermal oxidation. Okay. So, actually geosynthetics may be used for temporary structures such as access roads for construction sites, or may be required for medium term applications until consolidation of soils takes place and redundant. Long term applications are also used like 30 to 60 years and 120 years also. So, we have to see our material we are taking, is it good for short term, medium or long term, one should be very clear on this, then you can use it. So, you can find out its corresponding property and do that. Okay. So, resistance to weathering, what is that? It is essentially that the products exposed to uncovered light, if you do not cover them properly, the possibility is that they are exposed to ultraviolet rays, and the possibility is that it gets, see the thing is, you just leave, I have seen, you just take a geosynthetic material and leave it outside. Initially it is nice, but then after that, because of the ultraviolet rays exposure, whatever is the sunlight exposure, it gets very stiff and all that. After that you can just break it also with hand. We have some materials in our lab where you just leave it, if you do not take care of them properly, without proper coverage and all that, then you have to store, there is some requirements for storing. You just, so we have to store them properly and remove them and then put it in the soil. So, put it, you actually, it will not, if you expose it, it gets degraded, but if it is in soil, then there is no problem. Okay. So, ultraviolet test is one thing that we do. Then there is a what is called exposure to weathering. Tensile test after exposure and reference to fresh specimen tensile strength loss is there. Like you expose it to different material tensile testing, different degrees of weathering here. Like keep the samples for 1 year, 6 months, 10, like normally, say for example a PhD program, definitely that person can test for 2.5 years. Like immediately as soon as he registers, take the piece and then put it like this, so that is what people have done it in earlier case also, or put it in the soil and then see its tensile strength and all that, because they give some information and we have to compare with what is immediately, you test that, you get that material, you will have some number, like say for example 40 kilonewton per meter, then you leave it for a one week or a 1 day or something, then what is the tensile strength. So, you have to really do some testing here, which is very important. Then you have what is called resistance to microbial degradation, like fungi and bacteria living in soils may attack polymeric materials used as geosynthetics, and of course there is some test that like the advantage is that we bury them, so the exposure to outside thing is less, but even there is a possibility that some microbial organisms could attack. So, that needs to be examined. Of course, we do not have a we have a test for that. The test gives the different types of bacterial environments to be used. Okay. So, we have to essentially follow this test and whatever it reports is fine for us. Then there are some materials that are what one should identify. Say for example, if you are using a geomembrane, say there is a company that is generating lot of waste liquid and you want to store the waste liquid, you can't allow the waste liquid to get into the soil, right. You have to protect that, see the soil, protect the soil. So, you need to have some sort of a geomembrane system, you need to develop a waste containment system having a geomembrane, and that geomembrane should not get affected by any of the chemical processes. Say for example, the hydrolysis test. Say for example, if you have polyester based geosynthetic materials, there is a possibility that hydrolysis occurs and this material like a polyester material may get degraded. So, there are some specific tests for this, and say for example, you take polyolefins. So, they have a problem with thermal oxidation, like when they are subjected to atmospheric conditions, because of the oxidation and temperature the tensile strength will come down. So, you have to find out some of these weaknesses of these geosynthetic materials whether in chemical conditions or environmental conditions, and see that such conditions are not encountered. Of course, the conditions are not easy to overcome, but you have to choose a material that will not have difficulties when you have this type of conditions. Say for example, what people do is that they try to put the same material in different containers in different liquid agents and test them at different times. This is one type of test in which one can identify their properties. This is one simple test. Then resistance to oxidation, as I just mentioned, the to the molecule, the polyolefin molecules of polyethylene polypropylene, oxygen may be connected, creating increased brittleness of the polymers. As I said, brittleness is one thing that can because of the oxidation, it can just material what is soft, it can just after that it becomes wrinkles and becomes stiff and all that, and if you touch it, it gets broken. So what we do is that we have some materials called additives, stabilizing additives. So the moment you know that there is a problem with this material, so you have some standard additives that will delay this oxidation. So you need to have some sort of admixtures, like you have an admixtures in concrete, you have to do this. So for the test, the products are exposed to high temperature in an oven. So this hydrolysis is again something that hydrolysis of a polyester is a reverse action of the evolution of polycondensation and means connecting the water molecules or parts of the PET molecules, thus increasing the carboxyl end content and decreasing the average molecular weight, often expressed as solution viscosity. Actually what we do here is that this hydrolysis is something that is another serious problem in many of the polyesters. So we have to take care of this, and you need to create a proper conditions. So for example, why those things happen is that, see, because of this presence of due to this hydrolysis, the average molecular weight will come down actually. So there are some couple of tests that are done. So what we do is that the products are immersed in liquids for times up to 90 days and residual strength and deformation are tested. So you have a number of tests in this manner, and what we do is that we have number of testing procedures which are well established, and so what I would like to mention is that the geosynthetic the materials, you are using it for mechanical properties and then hydraulic functions. So for example, we know that the functions of the geosynthetic material are reinforcement, filtration, drainage, then moisture barrier, separation. There are so many properties that we studied as their functions. One should really use a proper application, proper you should understand the application and also get that property also properly. Like I have seen a case where a geogrid was used for erosion control. Geogrid, we know we use it more as a reinforcement. So if you use so whatever material you are using it for erosion control has to be exposed. Means, see, erosion control is nothing like you put a simple geotextile, and because of the atmospheric conditions, the whatever, say for example, take the case of a steep slope, 70 degrees or 60 degrees slope, and it is subjected to erosion, like because of the rainwater and all that, erosions are formed. So if you use a natural material like a jute geotextile or a coir material, the advantage would be that coir is cheaper and jute is also cheaper, and if you put those materials, what happens is that, and then put, actually initially you have to put that nice seedings, you have to put some seeds, then put this cover, and because of the atmospheric action and all that, though this jute and coir are supposed to be biodegradable, they just, you lose their properties within 1 year. But then within 1 year time, actually what this material does is that, because of this, you stitch the slope with the geotextile, erosion will not come, and at least for 1 year, and you also have within that 1 year plantations that grow up. When the plantations grow up, then there is a the erosion will not occur. So that's a beauty. So you need to understand that so for that, the type of testing required is somewhat different. Say for example, you must be able to find out the properties of the coir material, say for example its tensile strength, and how long, say for example, 6 months what is its tensile strength, and 1 year what is its tensile strength, and all that. The other important point that I would like to highlight to you is that there is a tendency for using say, as I just mentioned the case of a geogrid for erosion control. We have seen where it was not efficient. Why? Because after 1 year it formed wrinkles and all that. You do not need to use that material there for erosion control. A coir material would have been ideal. There is another case that I would like to mention, that the geotextile was good enough, because geotextile can take more deformation. Say for example, in a, like we have seen that geotextile can be used for protection layer, right. So geotextile layer could be used for protection layer. What it means is that if you put sometimes load also, it can just deform a bit, like it form a bowl, and it is, whereas a geogrid is not, it cannot work. So I have seen one application again where geotextile should have been ideal, but they used a geogrid. So they did not understand that geotextile can hold that material for longer time compared to a geogrid, where geogrid soil is allowed. It is the function there was to allow this retain the soil and allow only the water, and also allow that weight, some sort of deformation is also required there. So there geotextile should have been ideal, but then so like that. So one needs to have a good knowledge of the geosynthetic testing procedures, because you should know that their properties, how they vary with the time, temperature. Many of these materials are polymeric materials, they will have changes with time and temperature, and humidity and all that. So environmental factors are quite important. If you have a good idea, you can get you can really choose your numbers properly. Like so for example, you need say you are constructing a retaining wall for about say 50 years, and you need the tensile strength to be maintained up to 50 years. So for example, so you can use you can go to the company, ask a geotextile geogrid material which has say for example 50 kilonewton per meter, then apply all these correction factors, like which will account for mechanical damage, then environmental factors and all that, creep and all that. They come from testing only. All these correction factors come from testing, like we call them, say for example, partial factors of safety. In structural design we are familiar. Here also if you want to use it is called material partial factors. You have to get them by extensive testing and analysis, and once you get those correction factors properly for the time intended, it is fine. So durability is another important point. You should be understanding that, because our final objective is to ensure that the geosynthetic material you are trying to introduce, and it should see that say for example you are using for a landfill application. If it does not solve the landfill application, then there is no use. Like stability is another important point, because you are trying to improve the stability, and landfill should be safe and all that. So one should ensure the stability as well. So this is an important important aspect in the geosynthetic testing, the geosynthetic materials itself. So with this we will move on to the other things which are quite important. Thank you.